everyone. Thank you for joining in the first PDH hour with Glenn in 2025. I hope everyone had a safe holiday, enjoyable holiday, and I'm happy to have you all here, and hopefully they'll go smoothly today. Today's topic is going to be they did what? Question marks, exclamation points. Earthwork and geosynthetic project findings from the past year or so. I like to evaluate at the end of each year, personally and through in our company, and I think the industry should as well. Where do we stand? What are we doing good? What are we doing, that needs improvement? And ultimately, I hope these webinar and this session will help us grow. As a reminder, prior webinars, including this one, in a couple days after we're done, can be found on our website, www.cqasolutions.com. Find the training and education button, and then webinars, and then webinar replays. As a reminder to everyone, PDH hours will only be awarded for those who attend the live webinar and complete it. So I'll go over here real quickly what I want to talk to you about in the outline. I'm going to start with what I think are the foundation of projects, the construction documents, and then project planning. We'll go into earthwork, geosynthetics. We'll look at things we've seen in all stages of the installation process. Weekly meetings, daily field reports, certification reports, and I'll give you a highlight over the next webinar, and then we'll get into the questions and answers. And I'd like to remind everyone, I'll take questions at the end. You can use the question and answer feature on your browser and submit your questions, and I'll get those at the end. And if we run over or something, I'll stick around for a couple minutes for questions. So let's get started with construction documents. What are the construction documents? For the purpose and context of this conversation, they're your technical specifications, your CQA plan, and the construction plans, or the drawings, as many people refer to them as. So anyway, the construction documents, this pyramid of success, I think every project, starts with the owner involvement and accountability, begins with their vision, really, and culminates in the field work. And that's what everybody sees at the end. You can see your tangible progress. You can see the results of everything coming together, the design and all the other components. But the next thing that's most important beyond the owner involvement and accountability is really your design and specifications and having a good foundation for your project. And like I said, the construction documents really are the foundation of the construction success. I think having good documents really mitigates your risk on a project. These documents all need to complement each other, and they really provide the blueprint for how the project's not only going to be constructed, but for how the quality is going to be verified. And these seem like basic fundamentals, basic construction engineering protocols, but the reality is we're seeing that a lot of this is not being accomplished on many projects, unfortunately. So I'll give you some tips as we go along. And as I touched on, these construction documents are very important, but not only for, guiding the construction, but for the certifying engineer. If you look at the quote on the right, if it's not in the CQA plan or technical specifications, I can't enforce it. And unfortunately, that's a big reality in our industry. There's many times where, we've had people, or we see it during our audits, they have issues, and the certifying engineer basically is like, hey, it's not in the technical specification, it's not in the CQA plan, I can't enforce it. And I don't really know, whether that's true or not, if it's just out of their comfort. Sometimes they have pressure on them to get the job certified, but it's a reality there that the more that's in there, the better a foundation it is that can be enforceable. Some other quotes real quick. The owner has pushed me to the limits of my comfort in certifying this project. As I mentioned, there is that pressure sometimes, but if you have a good foundation document, good construction documents, as a certifying engineer, you should be able to say, hey, I don't want to do this. That's what my first boss did, John Hall of Hall and Associates. Back when I started in this industry, I overheard him one day on the phone with his client, and the client was yelling at him. And John said, I'm not going to certify this if we don't do it my way. We're going to do it my way. And I think, unfortunately, in this industry, we're missing that a lot anymore, and things get certified that maybe shouldn't because of the pressure. Um, and then another one is the regulatory agency approved it. The owner isn't going to want to hear that we need to do any additional work. So some of the conflicting information we've seen, if you look at this table on this slide, this is a compacted clay moisture density testing requirements. Moisture density test frequencies and lift thickness, the tech specs have different values there. Then they also have different types of lifts. One is a 6-inch compacted, another one's an 8-inch loose lift, and those two really don't translate very often in the field. 8-inch loose rarely compacts exactly to 6 inches. So if you convert those, you have one that's 806 cubic yards per acre or one that's 1,075 cubic yards per acre. And that also becomes important because the borrow source sampling on this site had a sample requirement of 1 per 1,500 cubic yards of fill material, but it didn't specify whether that's loose or compacted. So how is that interpreted? Do you have enough samples on your project? Those are all questions. Some may be minor, some are more serious that we'll look at throughout this. Looking at the same type of conflicting information in geomembrane, we're looking at the installation temperature requirements. Technical specifications say 40 degrees Fahrenheit based on a sheet temperature for a minimum, maximum 120 degrees Fahrenheit for sheet. Your CQA plan lists 32 degrees and 40 degrees, but they're an ambient temperature, and those two will rarely ever correlate, at least once the sun's out. They won't correlate anymore. And same with the maximum, it differed 120 degrees Fahrenheit for an ambient. But does that ambient really translate to 120 degree sheet temperature? I don't think that's going to happen very often. Just going to depend. So things like that need to be ironed out. But even within the CQA plan, these ambient temperatures, the ambient was defined in one place as 6 inches above the geomembrane, another place is 12 inches above the geomembrane. And there's going to be slight differences in the temperature at those elevations, especially with certain weather conditions, like it's cold and warming up, things like that. So in this case, the construction plans didn't mention anything, which, isn't uncommon for that. The manufacturer's installation documents, they had no mention of sheet temperature or ambient temperature. And I think this is a problem we're starting to see more and more in the industry is that the manufacturer's installation guidance documents have gone from giving a lot of detail to less and less detail. And, things get installed that maybe shouldn't be installed or welded incorrectly. Same thing with installers' installation documents. It's getting more and more rare that you actually see a document provided from the installer. Missing information, another example of missing. This one is where we had a material that needed to be hydrated like a GCL, but it wasn't a GCL material. But when looking through the daily field reports in our audit, we've seen that the temperatures recorded by the CQA technicians, were in the 20s, sometimes even lower, upper 20s or a little bit lower. So that raised the issue, they're adding water, they're hydrating this stuff, is there guidance on it? Well, there was no mention of it in the construction documents, your tech specs, your CQA plan, or your construction plans. But the manufacturer's installation document said it's not allowed. Precautions need to be implemented, like adding concrete blankets and things like that to make sure that if it is hydrated below and the temperature is going to drop below 32 degrees, that it's protected. Installation document from the installer had no mention, and the daily field reports had no mention that they did anything to, they just documented the temperatures, but and kept on deploying and installing. So, that's a bad thing to find out when you're reviewing a certification report, but it raises a question and really emphasizes cutting and pasting from manufacturer's documents or other documents can lead to problems, especially when important sections such as this are omitted. Communications, we've seen it, ever since I've been a technician back in the early 90s that documents are outdated and they're supplied to the CQA technician or the contractor. And that just results in a lot of unnecessary stress and sometimes costly issues. So mitigating the risk, how do you mitigate the risk with the construction documents? Um, Really, it starts with the owner, I think, and maintain involvement and accountability, require a peer review of designs, construction documents, and anticipate beyond the design, what else can impact it, that you might have to deal with down the line. Design engineers, stop the cookie cutter process, do a peer review of the construction documents as a whole, and then get out in the field, review your design for improvement. Some of the best design engineers, certifying engineers that I've seen do that. And they do exactly that. They get out in the field, they watch the design during the construction, see what hurdles and challenges the contractor had, and they figure out how to improve it. And I think that's a good process, but it just doesn't seem to happen very much. Most of the audits, and even in my career, it's rare that you get the design engineer out there, let alone a certifying engineer, other than for the mandatory once a month or once every couple month visits. And then regulators giving use discretion on giving advice. I'll get into why here in a little bit, but that quote that I gave earlier, if the regulator approves something, certifying engineers don't want to go back, and the owners expecting that if the regulator's okay with it, everybody else should be okay with it, and that's not always the case. So move on to project planning. One of the big things is a pre-construction meeting. This gives you your opportunity to make sure the project's going to be kicked off on the right foot. And there's a lot of things that should be done in that, and a lot of good things are being done in that. A lot of times safety is being discussed at least, so that's one good thing. But some of the things that we're seeing as issues are CQA personnel are left out of the meetings or not allowed to contribute much. Relevant installation personnel are almost always left out, so you don't have the foreman or the QC there. Um, no formal agendas that actually cover the technical requirements of the project. They'll give a high-level overview, but things that really are required that are going to become problems later aren't addressed. There's no site walk after the pre-construction meeting. Every one I used to attend early in my career, there'd always be a site walk afterward to make sure everybody was on the same page. And some of the things we're seeing really makes you wonder how the parties even reviewed the construction documents to begin with. The pre-construction meeting is a good way to verify that because they should have a list of requirements that everybody can agree on. And the impacts of having a poor pre-construction meeting usually results in delays, which results in increased cost. And we just had an example this year that I give here in the top bullet is, everyone was unaware of limited access due to a fence that needed to be removed. This wasn't found out until they're getting ready to do the anchor trench construction for the geomembrane, trying to beat winter. And, it caused delays and caused people to scratch their head, but that could have been easily avoided if there was a site walk with competent people and the right parties there. Cold weather seaming, GRI GM9, that's another one that we see, especially near the winter, is everyone just assumes that this document is plug and play during construction, and it's not. If you read GRI GM9, there's many things that need to be approved by the engineer. So the first day it drops below the 32 or 40 degrees, everybody's left scratching their head and trying to figure out what to do and calling the engineer, and it just causes unnecessary delays, especially when you're trying to beat the weather. So my suggestions for the pre-construction meeting include CQA in your meeting. Make sure that people are there from the CQA firm and that they're allowed to contribute. Include the installation foreman and the QC, as I mentioned. Um, Come prepared with an agenda relevant to the project that can be assigned out, certifying engineer, CQA, owner's rep, whoever. Come prepared with a summary of conflicts and requirements, anything that needs to be addressed so it can be ironed out in the pre-construction meeting. And then perform a site walk with all the parties and make sure that, if anything's seen, it's addressed and people can get it resolved pretty quickly. Project planning, as far as CQA staffing goes, we see several issues in CQA staffing. A big one is experience. It just seems like there's a lack of experience, um, for at least many of the projects we've been on. And just because someone has 20 years of experience doesn't mean that they've actually seen or dealt with certain issues too. So that's another thing that you kind of got to keep an eye out for. One of the biggest ones, though, is that CQA people don't seem to understand their role anymore. We're seeing a lot that are just out there documenting. And, we used to joke when I was out there first in my career, we're glorified wheel pushers or pencil pushers, because that's what we were doing, is documentation. But the documentation really is a secondary part of the role. You're really documenting what you're confirming with your eyes, and you need to make sure that things are right because documentation doesn't mean anything if it was done wrong. Um, and then part-time versus full-time oversight CQA. Um, that's a big one. Always, I think, is going to be a challenge, becoming more of a challenge maybe now because everything's so cost competitive. People are trying to find ways to cut down on their bids, be competitive. So, they go to part-time CQA presence. And I borrowed these photos from something Abigail Gilson had in her leak location presentation in 2016, but they're holes in the geomembrane that were found with a leak location, and they were caused by the dozer or equipment placing cover material over the geosynthetics. Well, guess where the first place people are usually willing to, go to part-time CQA? It's placing that cover material over the geosynthetics. All of a sudden, people want you to show up 4 hours a day or every other day. And there's a huge risk to that, especially, looking at some of the other concerns. Even if you have leak location, you don't want there to be wrinkles in the geomembrane. Even without leak location, you don't want there to be wrinkles. So there's a lot that CQA should be there present for. But unfortunately, the trend is to go light on CQA on things that are felt to be less critical. And then another project planning, captioned this one, surprise, we're here. There's nothing more fun than showing up at 6 a.m. on a job site as a lone CQA and finding you have an extra 2 or 3 crews there to deal with that are planning on doing install. And you call up the engineer, talk to the owner, and they just want you to handle it. One person as CQA really shouldn't be trying to handle one crew, let alone 2 or 3. And, my experience is I don't know that they ever actually come out ahead when they put these crews on, at least with competent CQA, because most of the time these other crews are not familiar with the project specifications or the requirements. So they show up, they do a job, and you find out they did a poor job and they have to redo work, and it ends up taking more time than the day that they were there. You end up spending 3 or 4 days fixing the stuff that they did wrong. So it's just something that people should be aware of, and there should be a plan. Certifying engineers and owners should stand up and say, no, you didn't give us any notice. We don't have anybody available to come out. You're not going to do it. or put in a requirement. We need 48 hours before you're going to have a crew. Something that's fair that you can allow people to staff it, but it's really not fair to your CQA people in the field to think that they're going to be able to cover two or three crews out there. So moving on to earthwork, several things here in earthwork. The first one really is materials. We see where material stockpiles, especially, quantities are missing there. The quantity that they were thinking was there, maybe they sampled in the spring, and then it gets to a summer construction project, and they find out, well, the owner used half that stockpile, so now they don't have the material that's pre-approved. Another issue we're seeing is that, and it's unfortunately happening way too often, in my opinion. It really should never happen because a lot of these times we're doing our audit, we're reviewing stuff after the project is completed. And it's the material that's been approved doesn't meet the specifications when you compare it. And it kind of makes you scratch your head because there's no documentation saying there was some type of approved variance for it. So I don't know what happens on that end when it gets to the regulator that might catch it, but it's something I wouldn't want to happen on my projects for sure. Another trend we're seeing here in the past couple of years really is the use of an E-gauge. It uses a different low-level radiation and different technology, really, two probes, one for moisture, one for the density that communicate with each other, Bluetooth, and give you the kind of the same results as the standard nuclear gauge. But these are all being used on jobs, and you talk to the owner, and they're like, "We didn't know it was a different type of gauge. Nobody got approval for it. The engineers are taking these out there, and they're not doing any correlation testing or anything like that. So is it approved? Is it not approved? That ends up being a huge concern. And it can lead to huge problems if you're using some kind of gauge that wasn't approved on the whole project. Earthwork, confirmation testing is another one of these big ones we're seeing here is that people are performing drive cylinders and sand cones to verify the nuclear gauge results or the E-gauge, where they get their density from the sand cone or drive cylinder, and then they have to do a moisture either overnight or microwave. And they're going through all those actions, but then they're not correlating the results back and plugging them into the proctor and comparing them to the test results. And what we see in our audits is when we do this, there's excessive failures. And there's no retest for these failures because the CQA firm didn't have them labeled as a failure to begin with. So to me, that's a huge issue. Um, it should be checked on a regular basis, and people need to make sure that these correlation tests are actually being correlated back, or confirmation tests are being correlated back. And another huge one that we see every year, this hasn't changed since I started in the industry, but desiccation. But one thing that has changed is now people are trying to dismiss desiccation because they're saying, well, the leak location will tell if there's a hole in the liner, and if there's no hole, then we don't have to worry about the top part of the clay. Well, my question back to them, if one, that's wrong, that really doesn't make any sense. But two, how can you say that you have your required thickness of clay and, your survey will say you have it, but you had desiccation cracks 2, 3, 4 tenths deep or even bigger in some of the cases. And that's not meeting your permeability requirements. So how are you certifying that? I don't understand it. But anyway, something to be aware of is a desiccation. That's really an ongoing battle. Um, Another one that's really become more and more frequent, I don't know if it's because more and more one-point proctor curves are being used. If it was just me and I was fortunate throughout my career that, most of the projects, I never dealt with a proctor curve or a one point until about 5 years ago on projects. So, I haven't seen them, but I know how to do them. And, maybe it's different state requirements or something, but we're seeing more and more of them. But people, again, are not doing it right. When you look at the AASHTO T272 guidelines, There's four requirements. It has to be the same material, classification. The proctor needs to be the same method, either standard or modified, for both the curve and the 1 point. Then your moisture has to be within 80 to 100% of the optimum. So the 80% is this left side of the blue line that I put on this graph. And then your density has to be within plus or minus 2 pounds per cubic foot of your density of the curve, and that you're trying to correlate to. So this blue box is where your test point should fall. Then if it falls there, that'll validate that you're using the right 1 point, or you're using the right curve, moisture density curve. But we're seeing, here's an example I put on here. We're seeing one that, falls way down here. And you're even lucky in this case. We're seeing a bunch that don't even fall on the graph itself, but yet they're saying that they verify the curve, which is impossible because they're not even on the same piece of paper. And these are being approved by the engineers. I mean, it's multiple places we're seeing this. It's uh, mind-boggling, I guess. Um, so earthwork, another thing, lift interface, this one, continues to be a problem throughout my career. You have too dry, lack of scarification, and smoothing of the surface. The biggest thing is the deployment method of the soil, and you get your load of material hauled by the scraper or haul truck or whatever it may be, and they dump it and then they drive across the previously compacted lift and it smooths it out. And then nobody bothers to fix that surface and get it re-scarified, make sure it's moisture conditioned. And that just induces a potential failure plane there, especially on these 3:1, 4:1 slopes where we're seeing this happen. Earthwork and proper testing procedures for the nuclear gauge. Yeah, more and more frequent here too. I think people, maybe they're, just going through the nuclear testing program or something, to get their certificate, that they're able to use the gauge, but they don't know how to use the gauge properly. Um, you're seeing where, there's requirements in ASTM D6938. It needs to have a smooth surface, and there's other requirements. No voids on the surface, things like that. But we've literally seen project after project where people are taking tests, and there's voids under the gauge. It's not set level. It's not set against the surface. They have a clay clot on the bottom from the previous test, and they're taking a test. And one project, they were having multiple failures that we were out there auditing. And the earthwork contractor brought in their own party to test. And that person came along and put the gauge in the same hole the other person did, which makes sense. You want to test that. But the test wasn't set up properly. So you have two parties there not doing any good. And as part of our audit, we pointed that out to the owner, and eventually they got it to where these things were passing because it didn't make sense. You could see that the compactor was riding up, the earth was firm, and they're failing it because of the improper procedure where your test really should be verifying what you're seeing in the field. That takes me to test penetration backfill. Sometimes we see where they're not being backfilled properly. Sometimes there's no backfill requirement in the specifications for compacted clay liners. And, the engineers, if it's not there, sometimes they'll be like, oh, you don't have to backfill it then. Somebody starts complaining about it. Moisture conditioning on days off is another big one. This is something we always try to address in our pre-construction meeting, but 4th of July, Labor Day, Memorial Day, all big holidays, and then you have the weekends as well where they might not be working, and nobody does anything with a clay, and they come back and it's desiccated, and they just unfortunately continue. They may water it down and start the next lift, and that doesn't really heal the desiccation. The good contractors will overbuild and they'll have people out there watering it. So right now, that's all I have for the earthwork until we get to daily field reports. But I'll move on to the geosynthetics here. Um, as far as safety goes, we don't see a lot on the safety end. There are things, safety-wise that we see from here to, time and time. But the biggest thing that really is consistent is we keep seeing these safety guards being removed from the coupon cutters. And those things are razor sharp. You can see this guy here, he's got his he don't even have any safety gloves on, and he's got his fingers right there next to the coupon cutter, and it'll cut down to the bone before you realize it. I've seen it happen to a couple people. So those should always be put on. And, I think as an owner, as a certifying engineer, you should make sure that, they are doing that. Insufficient ballast. This is, another one that continues throughout my career. Unfortunately, it just seems to be a trend that doesn't go away. And, here's a picture of insufficient ballast at the toe of the slope. Here's one in the anchor trench. There's been many times in my career as a CQA tech where I went up to somebody and said, "Hey, I don't think there's enough balance or ballast here." And come back the next day, it's blown out. People, I have it that I documented. I even talked one time to the owner, the engineer, and the installation foreman were all standing out there. And I said, "What about this ballast? It doesn't look good." Oh, they said it was good. Next morning, we had to repair an acres of liner because it blew out. It's pretty cheap and easy just to get the ballast on there and prevent that. It's easier to prevent it than it is to fix it or replace it. Rub sheets, they're rarely required anymore in the specifications for some reason. Usually they were required under every piece of equipment on the geomembrane. You see where, they're sometimes used by installers below soft areas or hard to work areas for their welding. So they can run their machines on them. And it's rarely specified anything about them anymore, whether they need to be removed, which they should be. At least the ones used for welding, if they're going to have a leak location, it's going to impact the accuracy of the leak location and ability to find a leak there. But this photo here shows one that's going to go under equipment, and the installer is actually being proactive and building in, a containment side to try and, if there's a spill, it's going to be contained. And we've seen on our audits and even on our own projects, installers won't do it, and all of a sudden you got a leak that goes all over the place because they didn't have a line, a rub sheet there, and the fuel or hydraulic fluid, whatever it may be, blows all over the place. As far as manufacturing goes, there's inconsistent texturing. Still, with certain materials, seems to be an issue. You can see in this photo, the right side, it's the same textured material as the left side. Might even be part of the same roll, I don't remember, but sometimes these problems start in the middle of a roll, so you don't know they're there. But, there was a fair amount on this project, and you wonder how it passed conformance testing. I mean, there's no way that any of this would meet the asperity height requirement. Um, and this should have been caught by the installer and the CQA personnel before it went down and got welded. But a lot of times that's not possible because everybody's, really busy on the project. For CQA, you got one CQA out. If they're watching something else, they miss something like this. But um, anyway, something needs to be monitored for that. Conformance testing. We're seeing another concerning trend here in conformance testing in our audits is that the number of samples that's required per the construction documents isn't there. They'll say you need a certain test, one per 100,000 square feet or something like that. And, you got a million square feet, so there should be 10 samples. We'll say there's 8 samples, and it doesn't make any sense. Sometimes it's per batch, and, that may increase your samples, but it's really a concerning trend, especially, with the geomembranes and even some of the others, geotextile, um, geonets, GDNs. We're seeing it with everything that there just doesn't seem to be enough conformance samples sometimes. Delivery and offloading, this is something really that we still continue to see, unfortunately, is that rejected materials are being delivered to the site. It's still you'll be out on a job site and people will bring in a roll of material because they ran out, which is, poor planning, but they ran out or, maybe they had to add something else, but it ends up that you see an X or something painted on the end and you look into it, and it's something that was rejected from a previous project. Excuse me. And delivering, offloading, handling, we still see, improper storage. In this case, the photo on the left, the roll height requirement was two or three, I forget which one, but it's stacked 5 high there, so it's well over the required height, which the manufacturers have that height there for a reason because they know what's going to deform their cores or cause damage to the material itself, as well as photo on the left. The protective wrappers being damaged, in this case, a textile product, and they're exposed to UV. That textile is going to degrade. It's not tarped. If they put a tarp over it, that would help. Excuse me. But we're seeing, a lot of these problems exist because people that are handling the material that aren't familiar with it, general contractors and such. Inventory, inventory control is really a big issue we're seeing is that, and I don't understand why. Because with all the technology, people using electronic control, you should be able to know how much material you have and such, how much material has been delivered, how much is approved, has all the ma approved material been delivered, how much material has been placed, will we run out of material? These are all questions that people can't answer when we're auditing, and it's kind of mind-boggling, especially on large projects, and you're getting material shipped in over the course of months, and you're rejecting material, and you're getting it replaced, and you don't know what you have. It's mind-boggling. I don't know how you can verify you have enough conformance samples if you have that. And if you run out of material, the ramifications are huge. It'll cause long project delays in some cases because if it's a specialty project or you have force majeure, like when the hurricanes hit and production's delayed, those delays can be long and they can really impact your project. And whatever happens, it's always going to be an increased cost to the project when you run out. So moving on to subgrade acceptance, we continue to see issues where it doesn't meet project requirements. But even more concerning really is, we have where regulators want to be out there on the first day of deployment. They look at the subgrade, deployment doesn't happen for a week or two, and the subgrade sits there, and now, the installer goes to deploy, the earthwork contractor wants them to deploy, they go to deploy, the subgrade conditions change, maybe it's desiccated or rocks, stones, whatever the case may be. But now you have the engineer and everybody else saying, well, the regulator approved it, but that doesn't make sense. It needs to be right. And another concerning trend is that no one knows what's approved and not approved. We see it all the time where the subgrade, you should know what area you've approved, use some cones, use something to keep a track on, but people just assume the contractor, the installer is going to stop and know where they go, and things get covered that shouldn't, and then they need to be fixed or repaired, and that just compromises the long-term integrity. So we'll move on to the deployment phase of geosynthetics. Another common one, that we can't seem to get away from for some reason is dragging materials on the subgrade on the ground, and that causes a lot of problems. A lot of times we're seeing where the material is getting scratched on the underside, as well as sometimes loosening stones that would have otherwise met specification and were okay on the subgrade. They get hit and they get pulled out, and people step on them and cause damage. Or in this photo, another common one we're seeing on slopes and even on flat surfaces is where the geomembrane is being deployed and it's rubbing up against the tracks of the skid steer. Well, it's a rubber. Everybody thinks that's okay, but you start looking, and we've seen where there's been holes punched in the liner, big scratches because there's stuff on the tracks. So it should be kept away from the tracks to be safe. I talked earlier about missing texturing for the material itself, but here's another seemingly more common issue we're seeing is this is like a micro spike agro material that has, it's a calendared geomembrane. And, you can see here, one side's black and the other side's lighter. That's because one side has a top side and one side has a bottom side. And if you talk to any of these manufacturers that do the calendared material, the friction angle is different between the top side and the bottom side, what they designate as the top side. So you got to keep an eye out for that. In this case, the certifying engineer said it was a small slope and it didn't matter, but the calculation for the interface friction testing probably was done with the other surface. So does it matter or doesn't it matter? And what's going to happen with the future of that cell? Are they just going to put in the designed waste or are they going to expand vertically? And things like that can impact the decision that's made now. So the best way is to do it right the first time. Here's a photograph of hand clamp damage. It's something we continue to see. People are using sharp hand clamps. This actually came from Solmax, their website, a sales brochure flyer. Um, but it just kind of points out, another one of my pet peeves in the industry. We're seeing more and more of it. Just seems to be bad advertising for our industry things, and conferences that I've seen, things on the website, things showing things that are being done wrong, like these photos, but yet they're out there, as promoting promoting their materials, promoting things, and it might just subliminally make people think it's okay or something. I don't know, but I don't like it when I see it. Here you can round your hand clamps, make it a lot easier, less damage, less likely to damage it. Although even with the rounded ones, we see careless installers drop them on the liners, so nothing's foolproof, unfortunately. Deployment, I call this one an oops, but it really is a bad oops. It shouldn't have been done in the first place. But in this case, the installer pulled the panel and didn't have enough material, and they ended up being short of the anchor trench. They should have put a different panel in there, but instead, they argued and the engineer let them put in a panel extension. And this panel extension was extrusion welded in, which is an inferior weld. So now you have the extrusion weld at a high stress area, as well as due to the length, a destruct was required based on the project specs. It failed, so now you got a cap. So now you have this quagmire of inferior welds in a high stress area. Just something that, you know, somebody should put their foot down and not let these things happen. Trial welds, I mentioned earlier, the QCs don't get the feedback they need, and a lot of times you see QCs and QAs not inspect for peel incursion. We always see samples not being welded on the correct subgrade, should be welded on the surface that your welding is going to be performed on. That's what's being done in this photo, so that's an example of a good one. A lot of times you'll see where, the QA has to go over to the QC trailer to watch trial welds or destructive coupons be tested, and it's away from the installation area. Um, a lot of times that's by design because the installers, at least certain installers, want the QA there so they're not seeing what's going on. And I've had many of them admit that to me. So I'm not making that up. I'm just saying it's something, to keep in mind. And maybe you need more manpower out there. Wrong crosshead speed, again, something we continue to see all the time. Overheating your thermal seams and both extrusion and fusion. For fusion, machines without operators and adjusting the machines in seam. Here's an example of a machine, we see it all the time, just left unattended, running around on its own. Here's an example where, the trial seam had the speed set here. You look 50 minutes later while it's in the seam and it's been adjusted, and the installer will switch it back before they do their end coupons, the last 10 feet. So that's something that, what do you do? There's never any guidance, if they switched it and you caught them switching it, what do you do? Well, the engineers will say there's no guidance, take a destruct, but do we really want to cut extra holes everywhere? We want to get away from that, really. Thermal seaming, the extrusion, forgetting to bevel, wrong welding rod, off-center welds. I'll give you examples of these here. Forgetting to bevel, the black liner, white extrudate's kind of nice, but you can see it was supposed to be beveled. So that's something that you need to keep an eye on. You need to be there because the black on black, you're not going to see it. Wrong welding rod, again, we see LLDP trying to be used on, and sometimes being used on HDP jobs. Off-center welds, you got to be there to catch that because once it's done, you can't tell if it's off-center or not. Poor grinding continues to be an issue. Unfortunately, you can tell when the grind's bad, and the grind's going to make or break your weld usually, whether it passes or fails. And then reheating, we talked about it a little earlier, but every one of these areas is overheated where they're joined together. This whole section should be cut out and replaced by one repair, fix a wrinkle, fix a crease that's there, but they could do it without all the reheating and potential damage to the geomembrane. Non-destructive testing, air pressure testing, wrong equipment. This photo here on the right of the text, these the air pressure gauges should be graduated for one PSI, and they're not. These are two. So they were using the wrong gauge out there, but nobody caught that. QC didn't catch it, and QA didn't catch it. Improper dwell time, not meeting your testing requirements. Improper starting pressure. This test, I'm sure was written down as a starting pressure of 30, even though it's at 32. But then what happens if it drops to, say, 28, and you're only allowed a 3 pound drop? They write down pass, but you've seen it fail. So you end up in an argument and you can make them redo it, but they should have the right equipment, should be doing the right procedures when they're out there. But unfortunately, we're seeing that there's a lot of failing tester installers aren't following the protocols and they're being missed by the QA. Vacuum testing, improper equipment, the gauge, the gauge is one thing you got to look at. I don't have a photo of it, but sometimes our units are in kPa or in inches of mercury, and people think they're PSI and they're not. But um, this one here, we're seeing, nobody inspected the gasket, and the gasket was causing it to leak through. The gasket had holes and cracks, and there's no way a valid air test could be done. But you can see this guy's been testing. Nobody caught it until we were over there showing them that, this gasket's bad. And that's because most of the time vacuum test operators don't even know what a leak is. Excuse me. Here you can see an example where they didn't get the full T on their vacuum test. And that often goes on. I have a video here. 30-second video where you can see the guy's doing his vacuum testing. And, the overlap should be your area inside this box, what you can see. It shouldn't be the part under the motor that you can't see because there's a gauge there. So you're really limited to this area. You should be overlapping within your visible area. But you'll see he's not even gonna get close to that. At least some of them will usually try and overlap the footprint, but he's skipping 6, 8 inches there. And um, so people need to keep an eye on that. Non-destructive testing, what we recommend, at least to help the QC, the person doing the testing, is do a hole on a piece of scrap liner. Make sure that scrap liner is discarded or thrown out so it's not used for repair, but make sure that the technician can identify a leak. Improper repair methods being used. In this case, they used a bead here. It should have been a patch over the hole. They're trying to weld over a wrinkle. Here they improperly terminated. They should have repaired this whole area, but even without that, there should have been a patch there at the end. They didn't do it. Trying to create patches or globs with extrudate. They're just overheating and ruining the geomembrane. Welding over wrinkles, something we continue to see. There's no back pressure when they're pushing down, so Probably over 90% of the destructs I've ever taken on extrusion over um, a wrinkle have failed. And that gets into destructive testing. And we see a lot yet where there's just meaningless requirements where the technicians are told, wheel off your destruct every 500 feet and mark it. But that does nobody any good. You're not evaluating any part of the seam, you're relying on random luck. And then we've also seen what's really a bigger concerning trend, or maybe as big, depending on how you look at it. But failing tests are not being identified by the CQA engineer. We're seeing this in certification reports when we do our audits and review. We recommend using destructs wisely. Put them where there's already defects. There's going to be holes, so you minimize the number of additional holes. Avoid flow line sumps, high stress areas. Wheeling off 1 per 100. We've seen them right in the middle of a flow line. You don't want your destruct in the middle of a flow line. Have the flexibility to meet project requirements. Ensure all the operators, machines, and interfaces are represented, and then give the installer the option to repair something rather than sample that location. And there's these GRI methods you can look up that provide guidance on minimizing the frequency in other ways. There's other creative ways to get it done. We've seen wrong break codes on peel and shear. In particular, your SE1, SE2 are applicable to shear only per the ASTM. And we're seeing those from laboratories on peel test and vice versa, where SE3 is on a shear. And that makes no sense. I don't know how that happens. And it's mind-boggling, I guess, because how can anybody say you have the right thing? How can you have any confidence in your lab if they're not getting it right? Failed or improper tracking of destructs. Here's one that was bounded, passed, but they never did any repair. So when we went back through the paperwork, we're like, hey, there should have been repair here. Final walkthroughs in geomembrane not being performed. That's another big one. So um, people should be looking at the product. And then another big one that we see is, everybody approves the ATV. Yeah, they can run all over the liner. Well, when they run over the liner that's wrinkled, they leave all these creases. And then the engineer says the creases can stay because he has no guidance saying otherwise in the construction document. So you end up with compromised liner systems due to compromised construction documents. I'll move into weekly meetings. I know we're getting down on the last 5 minutes here or so, and I still got a few slides to go through. A big thing, I've touched on it already. Nobody has a clue on materials. No one's tracking quality indicators such as trial welds. So we recommend that you use a weekly summary report. And then I'll blow through this one pretty quick because I got multiple slides. This was a pretty intensive one on a big project, but we looked at trial seam, seaming, all the membrane quantities on a daily basis, and we provided it to the client weekly. Sampling frequencies, what were our sampling failure rates? Vacuum test, extrusion repairs, how much footage, how many tested, spark testing, leaks found. You document everything that goes on, tracking, you know. We had rejected materials, so we monitored the suspect material, we monitored rejected rules. All that should be able to be provided to the owner every week, especially with today's technology. And so I'll get into the daily field reports here. One of the biggest things we're seeing really is a lack of relevant data. You look at daily field reports, you can't piece together what was done. There's just not enough data. And the daily field report should help you understand what was done. Then we see that the data conflicts. There's conflicting number of tests mentioned don't match when they actually do have the information. Their photographs in particular lack or contain conflicting or damaging information. And then, this one is huge to me is the reviews. We've seen even up to 8 months before the engineer signed off that the paperwork was reviewed, which makes no sense. You can't catch anything if it's 8 months after the fact. Earthworks, there's no way of tracking anything. There's no lift maps. You don't know the volume. So how can you track if you're using the right number of samples or not? There's no way to figure it out. Specifications, rework, protocols aren't being followed. And, again, the equipment's not provided. Geosynthetics, the same thing, too vague on quantities. I mean, right now it's easy to cut and paste, at least descriptions, no quantities. Improper terminology. I meant to mention one for earthwork where they used soil and in the report, and it was used for 3 or 4 different components. So how can you have any assurance at all that they were using the right component, you know? Was it the structural fill soil or, you know, what was it? Nobody knows. Same with fabric on geomembrane. Fabric was used for project with 4 different geotextiles, non-woven, woven, reinforced, or high strength. So how do you have any idea that they used the right one? No pictures to go with it, and the pictures that were there were too vague to tell what was used. And that goes right into the certification reports. The narrative does, excuse me, doesn't match the contents of the report. You know, a lot of the stuff that we discussed today, we were getting out of our audits on of of certification reports that were either provided to the owner or going out to the regulator. You know, and I don't know how anybody can turn in some of this stuff. The contents are missing, incomplete. What they say is there isn't there, and then there's a certification statement that's signed, attesting that to the best of your knowledge, the project wasn't um, completed in accordance with the construction documents, basically. But how can you be putting that in there if you have, many of these things that I've shown you here in this report? That's one of my biggest concerns is we gotta all button up here um, and make sure we do a good job, hopefully if I'm going over some of these with you and that'll help you guys figure things out and we can all rise together and train people up and make a better industry. That's my hope with all this because there's a lot of things here. Some of them are minor, some of them aren't. But, I think that there's no reason we can't have successful projects anymore. A lot of it just seems to be maybe we've lost touch with the foundations or something like that that we should go back to fundamentals. Um, so that's really my presentation here. Up next, I'm going to give you, I guess, everything you ever wanted to know about destructs, February 20th, again, 12:30 p.m. And yeah, everything you ever wanted to know, and maybe some stuff you didn't want to know about destructs. But yeah, I'll take question and answers. I know we're right at the hour mark. I apologize for my glitch in the beginning and commit to getting that right by the end of the year. Hopefully much sooner, but one of these days I'll remember to share the screen. Um, so yeah, is there any questions and answers? Or questions I'll try and answer. Uh, let's see, I don't see anybody with any questions, so I'll give you another moment or two here to shoot me a question. Or some people might want to shoot me, but not any of you that are watching, I'm sure. But yeah, I thank you for attending, and I look forward, to working with you and talking to you throughout 2025, and look forward to seeing these list of concerns that I presented today, shrinking for when we do this again in a year. So thank you very much. And yeah, I'll see you in February.